Dear participants, very good afternoon and welcome one and all present here on second session of day 1 of ATAL sponsored 1 week FDP on emerging trends in photonics scheduled from 8th January to 13th January 2024. Organized by Electronics Engineering Department, Rajki Engineering College, Sonbhat. It's give me immense pleasure to introduce and welcome our eminent speaker, Dr. Kumar Pandey sir, who is Associate Professor at IIT Patna. Now I would like to invite Dr. D.K. Tripathi, kindly welcome him with a bouquet. India in 2007 and 2009 respectively, and PhD degree in Optoelectronics devices from IIT Indore in 2014. He is currently working as an associate professor at Electrical Engineering Department, IIT Patna. He has authored and co-authored more than 110 papers in the International Journal and Conferences of Repute. He he has also co-authored several number of book chapters on optoelectronics devices. His research area includes modeling, simulation, and fabrication of optoelectronics devices, including solar cell, gas sensor, and photodetectors. Dr. Pandey is a life member of Indian Society of Technical Education and associated with other reputed organizations. He is an active reviewer of several international journal of repute. Sir, we are very glad to you have a here. Thank you so much for accepting our invitation. Sir, you are requested to kindly start your session. Sir, over to you.
Hello. आवाज आ रही? Okay. So, first of all, I would like to thanks Dr. Prashant sir for giving me an opportunity to discuss my views and thoughts related to the optoelectronics devices, and it's really a great honor and privilege for me to be a part of this event, this faculty development program for the photonics. So let me start. So I like to change this one. So full screen. अच्छा ऐसे करके ना हाँ तब तक ठीक है no problem. Okay, so today I'll be going to share my thoughts and views on recent trends and developments in semiconductor optoelectronics. So let me start with the terms. We know that today, if the today is analog, the future will be digital. Already Modi, Prime Minister Modi already told so many things related to the digital part. If today is electrical, the future will be optical, and if today is core, the future will be interdisciplinary, right? So we all know in this modern era, with the advancement of technology, the research areas in the field of optoelectronics devices has found a great potential. As we begin with the 21st century, the nanoscience and technology are making a rapidly and revolutionary pace in all the domains, whether it is physics, chemistry, mechanical, electrical, and so on. Now, the most impressive research has been done in the field of semiconductor technology. Yeah. So, before starting with the talk, let me introduce my institute. IIT Patna was established in year 2008, an institute of national importance. Patna, anciently known as Patliputra, it is a land of Lord Buddha, Mahavir, Guru Gobind Singh. Even various eminent personalities like Aryabhat, Chanakya, Chandragupta belongs to this place. I hope you are all familiar with these names. The main campus of the IIT Patna was inaugurated by Prime Minister Shri Narendra Modi on 25th July 2015. The institute is sprawled in an area of 510-acre campus. We have 10 departments and 3 centers. Okay, now let me tell you about the research group that we have encompassed in the IIT Patna in electrical engineering department, that is the SORG group, Sensors and Optoelectronics Research Group. We generally work in all these various domains, including material growth, device modeling, then measurement, then fabrication and characterization part. So you can see we are targeting majorly 4 or 5 different domains, right. So my even the whole study qualification is itself a interdisciplinary. I have done in BTech in electronics, MTech in physics, PhD in electrical. There I teach in mechatronics, that is a part of mechanical engineering department, and my research is in material science, right. So we generally work in all the domains and do the first modeling, simulation and analysis, and later on the fabrication aspect. Okay, so here is the outline of my talk. First, I will discuss you about the motivation behind the use of optoelectronics devices, why nowadays people are moving towards this technology, this domain, why it is so popular. Then further development trends, what are the major breakthrough that has been done in this particular field area. Then what are the different types of optoelectronics devices, what are their characteristics, their pros and cons. Then we will going to discuss about one more important area, that is the biophotonics. Then I will be going to discuss about the science of miniaturization, which is simply the study of making small things. Then what is the nanoelectronics impact on society, and what are the various challenges, and concluding remarks. नहीं अभी नहीं मूव हो रहा. हाँ नहीं लेके हाँ नहीं किधर वाले कोने से. अच्छा हाँ हाँ इधर से कर सकते हैं. नहीं सिंगल हाँ okay, thank you. Okay, so let me start with the very basic things. Okay, I am not here to discuss you about some of the research in-depth analysis related to that part. So it is just a general talk overview related to the optoelectronics devices, so that one can easily understand what is that particular devices and why, what are its applications, right. So the things, let us start with the ancient era, long before the ages when the different ages of things were going on. So we all know about these ages, that is the Stone Age, Bronze Age, Iron Age, right. Achha. Next was the Ice Age, also I have you have seen. So what will be the next age? What is the present age in which we are residing? Can you tell me? What is the present age in which we are residing right now in 21st century? Any idea? So that is information age. So basically one of a great scientist has mentioned that the data is the new oil. Information is a very big and the capital asset nowadays. जिसके पास information है, that person is a really a bit person. So basically nowadays the cost of transmission and sending information, data is available at any place, any time, anywhere. Okay, so these things, you can say the information is now became a very important capital asset, and all these are possible only because of the revolutionary ideas that nowadays are going on into the particular system. Okay, so this capital asset, this information or the data that is available in different forms in all over the region is playing an important role in the innovation and giving up a idea or thought what to explore for the next generation technology. Yeah. Now one of the important thing, it is interesting to know that the major important scientific contributions or inventions like transistor, maser, laser, integrated circuit, LEDs, optical fibers, solar cells, all are invented by the physicist. Okay, I hope you all know about these different terms. Transistor, that was invented in 1947 by Bardeen, Batin and Shockley. Shockley is considered as a father of transistor, and he invented the first PJT part. Maser and laser, microwave amplification by stimulated emission of radiation, and light amplification. We will discuss about these things. Integrated circuit, Robert Noyce and Jack Kilby in 1958 they have invented. Then LEDs, all are invented by the physicist. So that is the main concept, is for all the backgrounds, engineering related part, the physics is the base one. Okay, now let us start with the term optoelectronics. Okay, so first let me tell you about the photonics term, because obviously this thing is related with the photonics part. So photonics means basically the study of the light related phenomena. Okay, so when we are dealing with some sorts of generation, detection, modulation, amplification, manipulation of light, that is dealing with the photonics part. So optoelectronics is also an amalgamation of two terms, one is optics, one is electronics. So how we are dealing the optics, that is the photons part, for electronics applications, that is called as optoelectronics. So basically here we are trying to create and correlate the two terms, the photons with electronics applications. So optics means, you know, light, the renewable source of energy, the photons. We know the basic formula, E equals to h nu, that E equals to h t by lambda. There we can calculate the basic fundamentals, and this basically optoelectronics, we are converting the electrical to optical and again optical to electrical system, obviously to make the system more compact, robust and more secure, right. So there are various advantages of optical systems over the electrical systems. Let me give one very basic example. In electrical system, mostly we are working toward in the range of bandwidth range of few megahertz, right. In optical case, we are working in the range of going in the range of 500 terahertz. So you can imagine what is the difference, such a higher bandwidth, and they have lower attenuation, smaller size, signal security, reliability, so many number of factors are there. Okay, so there are various applications you can see that is used in guidance, control, communication, defense, health, everywhere. So optoelectronics has ground to space level applications. Okay, so one simple and basic question, can you tell me how many kinds of displays are available in the market? If you have seen somewhere, so
just like LCD, AMOLED displays, TFT displays.
so ये 3 बताया आपने अभी. हाँ. So no, that's why I told you how many types, if you know, so you can tell me. There are various sort of displays that is available in the market. Mainly people generally, let's say I will give you an example, because generally we are not known about these things in a better manner. Let's say we go to Reliance Digital or some other showroom, na, they will tell you the each of every details related specifications related to a particular system, whether it is computer screens or mobile phones or TVs or anything else. They know every details. That's why even I myself, when I used to go there, and then उसके बाद उससे details खरीदना है, that is different thing, but बाकी details उनसे पूरी कुंडली बता देंगे वो, right. So that is a good thing related. There are more than 120 types of displays that is available in the market. You won't believe, 120 types of displays, and that is of different categories and different characteristics, features. Means not only these things are foldable also, right. The main thing is that nowadays people have bigger expectations from the smaller devices, right. Best example is mobile phone. मोबाइल में सब कुछ होना चाहिए, everything we want, right. जितनी भी चीज़ें हैं, everything we want, but ऐसा बोलते हैं कि पैसा भी जितना मर्जी हो ले लो, no, not possible, ना. So that is the thing. So cost performance factor has to be maintained. best facilities within the cost effective manner. So that's why we generally look into those factors. ये तो नहीं चल रहा है शायद, हाँ यही बेटर है, हाँ कोई okay. So let me tell you about the motivation part. So optoelectronics field has three major motivations where we are used for the societal benefits and day-to-day life, right? So that is the medical, biomedical system, the consumer electronics, semiconductor lighting. So in the biomedical system, we all know that now these devices are making a great breakthrough into the system. Let me give you one very basic example, like LED laser, that is optoelectronics devices that are used. So for laser, you have seen at various hoardings or this one, यहाँ लेजर के द्वारा आंखों की सर्जरी की जाती है, राइट? इंसानों पे भरोसा ही उड़ गया है. So basically अगर मशीन से ट्रीटमेंट करेंगे, so that will be more effective or more better as compared to this one. Okay, so that's why there are various sort of devices which are used for this sort of treatment and diagnostics. Okay. Okay. Yeah. So now besides these, there are various other applications where these optoelectronics has found their important role, including the cell phones, digital cameras, even hearing aid, computer systems, automotive, everywhere. So they are playing an important role for making towards moving towards the automation system. Now if we'll talk about the basic sources, LED, laser and these things, the main two classifications include continuous wave based system and the modulated light system, that is generally used in the laser part. And there are various again applications part, including from the transistor level to the spintronics device, then optoelectronics, photonics and various other. Now the important thing is what sort of materials are used to make these optoelectronics devices. So they are basically classified into three different parts. One is the fourth group material, as previously people were using silicon and germanium based material, compound semiconductor materials. Then after people have moved towards third, fifth group material, that is nitride based material, and later on people move towards oxide based materials. So basically that depends on what are the different properties related to these materials, whether it is thermal properties, mechanical properties, electrical properties. Based on to that we generally choose that particular material. Okay. Now let me discuss about the basic things, somewhat more history related to this, like invention of transistor that was done in 1947. Before that we were using the vacuum tubes, which were very bulky, very unreliable, power hungry and different issues were there. So the most important breakthrough and contribution was done by the Barton, Brattain and Shockley in 1947, when they first invented the first transistor. Okay. So that was the major breakthrough at that time. Now second thing was related to the optical system in communication part. We all know right now at various places we have seen the optical fiber systems that is used for the communication part, long haul distance communication. Why? Because optical fiber systems are very fast, light in weight and can be cover the signal for the long range, even with the very low signal losses. In electrical system there are very high losses, be 8 dB, 10 dB or more than that. In this one initially 2 dB was there, then reduced to 0.5 dB or 0.2 dB losses were there. Now how the revolution has came into the solid state lighting part. So that is somewhat interesting to know. So from the 1000 years ago and all that, people were initially started with the brick part, right? So they have started using that sort of open fire for fulfilling their basic needs, right? Later on that things have been moved towards the tamped fire. वो राजा महाराजा के उसमें आपने देखे होंगे, जैसे वो महल में जलाते थे दीपक and all those things. So the thing was that how we can try to mold the characteristics and features of lighting that was developed in a more proficient manner, and then after the invention of this bulb, the things have been changed drastically in this particular solid state lighting domain. So it is very interesting to know that how this light applications, the photons applications, are used for the electronic systems. So we all know the basic concept that whenever the photons strikes onto a semiconductor material, the electrons emissions are done from it, right. So that is basically the concept which is utilized for different applications, and these photons are generally playing an important role in different application part. So light, we all know that it is a free energy, renewable source of energy, and light is having the both nature, particle nature and wave nature, right. So wave particle duality, I hope you all have studied about these things in the physics 1. So basically these things, wave nature and particle nature, both are supported by the different phenomena that you have studied, propagation, interference, polarization, and the wave particle nature was supported by the photoelectric effect part. Okay. So this is very interesting thing that the whole electromagnetic spectrum is divided into subcategorized parts. So IR region is there, visible region is there, UV region is there, and each categories are utilized for different application part. Okay. So UV visible region are utilized for making ultraviolet photodetectors, then after some light source part. Visible region is utilized for making different LED laser sources itself. Then IR regions are also utilized for making the IR detector systems, then LED system, and so on. So basically the main concept is each region is specifically utilized for different application part of the spectrum. So here we will be going to discuss about few optoelectronics devices, that is the LED and laser mainly, then optical detectors or photodetectors, then further display devices, solar cells, etc. So all these important devices are playing a crucial and significant role nowadays in our day-to-day life. Okay. Okay, so let me start with the optical transmitter. Obviously the optical source part, that is the optical transmitter which converts the electrical energy to the optical energy, right. So that is the LED and laser. Okay. So these two are the optical transmitter, and the optical receiver includes the photodetectors, that is PIN, PN, and avalanche photodiode, I hope you all know. Then besides that we have the photomultiplier tube, phototransistors are also there as a receiver part. Okay. So let us start with the LED. Nowadays even small kid also knows about the LED, right. उसको remote पकड़ाएंगे वो TV on करता है, so वो छोटी जो light जलती है, he knows that this is the LED, if ये जलेगी then TV on होगा, right. So that is basically a two-terminal semiconductor device which emits light when forward biased. Okay. So basically LED is very simple circuitry, and it is utilized for most of the applications where we are making a circuitry related to the electronics, instrumentation, and other allied areas. Only the thing is, it has its characteristics are such that its applications are somewhat limited. So it has incoherent output light, it is its light beam generally diverges. So basically because of that it is used for only short range area part. So all these limitations are covered by the laser, that is the light amplification by stimulated emission of radiation. So laser beam is perfectly monochromatic, highly intense, produces coherent beam light, then high modulation speed, converges to a single point. So all these are features of laser, because of that it is utilized for specifically biomedical systems. So let me tell you the different categories of LEDs which were used: planar LED, dome LED, edge emitting, surface emitting LEDs. So initially people have started with this one, this planar LED initially, only P and N junction material. Okay, so at that time there were lack of resources, so people were happy to make only very small simple sort of structure to fulfill their needs. So for that only 1% efficiency was there, so very difficult, that was quite unreliable and not very good things related to that. So then after the new changes that has been made was dome LED. So you can see the structure was made a hemispherical shape of thing to further improve the light emissive properties. So this mainly gives the this mainly gives the 5 to 6% of efficiency. So people were somewhat happy, okay, now this is producing good one. Now in around 1940s, 30s or 40s, the boom came in solid state lighting when Dawson and Burris invented the first edge emitting and surface emitting LEDs. So that was purely based on to the heterostructure material. So you can see the different materials, third, fifth and second group material are utilized, having a large emissive area. So their efficiency was quite higher as compared to the previous counterparts. Then after that, one super luminescence LED was also there, that is giving a high power LEDs. Now we all know this, the basic concept, absorption, spontaneous and stimulated emission. So the Einstein has given these three basic fundamental rules, and because of this one, that was utilized for different application part. Okay. Similarly, we have different sort of lasers and categories that involves having a very active medium is there, the two fully and partially reflective mirror. So whenever this active light source that moves back and forth, very fast movement is there, out of that 100,000 moves, only one small beam of light that comes from that partially reflective mirror, that is the laser beam, and that is of very high resolution, extreme intense, and that is why it is utilized for different application part including the biomedical. Similarly, we have the distributed feedback laser, vertical cavity surface emitting laser. All these lasers are utilized for different applications including optical fiber communication system, instrumentation and the other sectors. Now similarly, we have optical receiver. Once we have converted the electrical system to optical system, obviously it will travel through a medium, and at the receiver end we have to recover the original signal. So for that we use the optical detectors or photo detectors. So that converts the optical system to the electrical one. Again, along with that, since the light that source then travels from one medium to that one, so we have to use some sort of analog processing system, signal processing system, so that the signal should be recovered as usual from the transmitter end. So for that we generally use some sort of filters, we use some sort of amplifiers to gain the signal. Similarly, photoconductive light detectors are there, which is used in the system having a larger band gap energy as compared to the semiconductor materials, and this generally creates the free electron hole pairs, and based on to that we generally utilize this for different application parts. Then we have the different categories related to the photodetectors, including photoresistors are there, then phototransistors are there, and that is generally their main role is to convert the optical into electrical part with different resistive phenomena or the amplification phenomena part. Besides that, we have one more important detector, that is the photomultiplier tubes, that is somewhat like a quartz glass like tube in which the diodes are there, that generally produces a very high gain inside the system, and because of that it generally gives a very good efficiency and very low noise part. So lesser the disturbance, better will be the performance part in the system. Okay. Now one more important photodetector is solar cell. We all know that now people are moving towards the solar cell system, because everywhere the renewable source of energy are providing a better attractive solution. Nowadays, at many colleges and institutes buildings, people are using solar panels to generate the electricity part. So that is one of the biggest advantage related to the electricity system, and this was basically based on to the principle of photovoltaic effect. So the generation of potential difference when the photons are induced onto the semiconductor material. So for that, Albert Einstein got the Nobel Prize in 1921 when he discovered about this photoelectric effect part. So initially, again, the solar cell efficiency was very low, 2 to 3%, 5%, but later on after 1990s, the efficiency goes up to ohm by using silicon based solar cells. Okay. So what is the motivation behind using these solar cells? So the most important thing is the global warming and climate changes are already there, right? So initially, when I started my journey from IIT Patna, the weather was good. When I reached to Allahabad, then it was raining. So the climate changes in such a small region of distance itself. So because of these global changes and warming and all these several external factors, the things are affected a lot. So we have also issues of short running oil resources, and power demand is already raising. So it is very difficult to fulfill all the criteria related to that. So the only solution is solar cell, and that is the compound semiconductor solar cells. So that provides a better alternative to these non-renewable or these fossil fuels counterparts. So these are some of the basic equations of the solar cell that is generally used to calculate the performance factor. That includes the short circuit current density, open circuit voltage, fill factor, and the power conversion efficiency. So whenever people are working towards the theoretical aspect, he has to first analyze these factors, then only he can move towards the optimal performance of a solar cell, different categories of solar cell. So solar cells are used generally for different applications, including UANC, in a small region, park, office, everywhere people can utilize these solar cells for different applications. Now let us come to one more important device, that is sensors. Okay, so we should start from sensors from our body itself. Our body is itself a sensor, right? So we have 5 sense organs. So sensors even are embedded in our bodies. They are present everywhere, omnipresent. Okay, so they have different applications, and we can't assume automation without use of sensors. Generally, people says about smart cities and all these things, that starts with the smart sensors, right? So until and unless everywhere these smart sensors are placed, we will not think about of making any sort of system smart. Okay, so sensor is basically a device which responds to physical stimuli, which converts non-electrical mechanical signal into electrical signal. Okay, so it is basically a form of transducer, you can say. So yeah, so they are embedded everywhere, including the automobile system, including the aircraft system, missile system, everywhere nowadays sensors are present. And so it is very difficult to achieve automation without help of these sensors. And the most important role again sensors is in biomedical electronics part. Okay, so in engineering part you have seen for all of the system. Okay, so as I have already told that although we are moving toward the digital systems, but the fact is the real world is analog, right? So I hope you have all visited the ICU room, right? वहाँ पे देखते होंगे पेशेंट का जो चलता रहता है हार्ट बीट, राइट? तो ये चलता है तो ठीक है, स्टेट हो गया तो देन गए, राइट? So that is very important. Okay, so continuous होना चाहिए. So the real world is analog. Okay, so that is used for different parameters or different, whether we are using any sort of EEG signal, ECG signal, EMG signal, cardio signal, everywhere we have the need of these sensors. So people are nowadays working towards these sensors for these applications. People are now looking towards treatment of cancerous diseases and the similar sort of diseases that can be cured and that can be detected at the early stage. Okay, अगर डिटेक्शन में लेट हो गया तो पॉसिबल नहीं है बचाने का. So that's why people are working towards these devices. Next is biophotonics. So again it is a two term which includes the amalgamation of this photonics and the biomedical science or biological science. So that here we are using tissue engineering and the various sort of optical communication systems, then light manipulation strategy and the other things, so that it can be utilized for different application counterparts. So biophotonics also finds the application in the field of life sciences, the various medicine, agriculture era, environmental science, in this biomedical systems, horticulture part, and generally utilized for different applications quantitatively and qualitatively both. Okay. Now you all know about the few terms that is generally computer science people used: artificial intelligence, big data analytics, this and that. We also have some terms, electronics people, so that is generally new. Let me give one example. So maybe if some of you have seen previously in 1990s or all that time, वो CRT टाइप का पिक्चर ट्यूब यूज होता था, देखा है आप लोगों ने, राइट? सो CRT के बाद फिर नेक्स्ट क्या आया? LCD आया, फिर LCD के बाद क्या आया? LED आया, हाँ चला LED प्लाज्मा दोनों. देन आफ्टर क्या आया? OLED आया, MOLED आया, देन नाउ QLED. So quantum. So the future is quantum based system. Okay. So now we are working towards this quantum technology, that is purely our field, our domain. Okay. So you can say now the future will be quantum and people are working towards that. Similarly, one more term is there, ambient intelligence. So it is somewhat like that, that the things can be fulfilled based on our need, comfort and convenience, right? Let me घर के अंदर आए, गर्मी लग रही है, पंखा ऑन हो जाए, ऑन हो गया, ओके, दरवाज़ा खुला छोड़ दिया, शटर ऑन द डोर, दरवाज़ा बंद हो गया, राइट? So that is basically based on to the thinking mind of the particular person as per their comfort. हिलने की जरूरत ही नहीं है, राइट? वैसे ही आदमी आज के टाइम में इतने बर्बाद है कि कहीं कुछ करने का वो नहीं रहता. So that is somewhat the ambient intelligence, where the things are responsive and sensitive based on to the presence of people. So it is basically main into the adaptive part and the context aware things. Okay, one more thing, important thing is there in our system, that is Wi-Fi, the father of Wi-Fi. So Wi-Fi we all know that, right? So कितना स्पीड होता था Wi-Fi का?
वाईफाई का 5 GB पर सेकंड होता था, बट इसकी से 100 GB पर सेकंड.
हाँ, बेसिकली इनिशियली जब हम लोग यूज़ करते थे, मुझे 2 Mbps 5 Mbps की स्पीड आ रही है, ये वो करके समा वो करते. Wi-Fi has theoretical speed of 10 Gbps. So you can imagine such a high speed, means कि कोई वीडियो डाउनलोड करना है, कोई मूवी डाउनलोड, it is done in a fraction of seconds. So that is the light fidelity. Okay. So basically what is this system? This system generally uses this sort of our light, that is somewhat LED or this laser part, and this internet or all these systems can be used in the term of discrete signals, that is in the binary form. Okay, and you can utilize, you can do the net surfing part and for a particular time duration and can put in rest. So basically the, let me show you the block diagram. So it is somewhat like this. So we have this light source and the modulation system, that is obviously that is used into the things, and we are using some sort of laptop or desktop system, and at the photo detector it is again converting that, and we are recovering the whole data. The main important concept of Li-Fi was introduced because in Wi-Fi the data hacking and all this was a very serious issue. But 0101 इसको कौन लाइट को कौन हैक कर पाएगा, right? So that is very difficult. So that's why that is the most secure form of transmission, data transmission. Okay, that's why people have moved towards this one. In India, only few people are working towards Li-Fi, including IISc Bangalore. You can Google through it. Okay, so you'll find. But in foreign countries, Germany, Japan, Korea, everybody are using. Okay, so we are lagging behind. But this is the future part. Li-Fi, quantum technology, all these systems will going to make these things a drastic change. So this is somewhat the operating procedure for LED one on and off. Then they generally quickly respond based on to the transmitting and the receiving end data. So that can be used for array of LEDs also for parallel data transmission. So you can see the theoretical speed is 10 Gbps. So that is quite high as compared to the Wi-Fi system that were previously used. And this is somewhat the comparison between the Li-Fi and the Wi-Fi system. Having a wide spectrum range, cost is also lesser, operating frequency is also quite high, data transfer is also good. So the most important application is in aircraft cabins. Generally use करते हैं, so there you use that, and then you can serve the internet. So that is one of the best example where we can use this Li-Fi technology. Then at the various lamppost and the access points at the at different public access points where we can use, but that will be somewhat quite difficult because then people will not move like this, people will move like this one. So that will be very difficult. वैसे ही mobile में it is very highly addictive and very different things that people are using. अगर lamp post से भी use करने लगे internet, so then people will start using things drastically. Then underwater communication also we can utilize this Li-Fi system. So for ocean navigations and for the military part, they can also use this Li-Fi underwater communication. So that is one of the best example for the Li-Fi technology into the system. Okay, now let me tell you some basic factors that makes the drastic change in this, not only the semiconductor industry, but also onto the which affected the all different domains related to their work. So in 1958, Jack Kilby and Robert Noyce at the Texas Instrument has developed the first integrated circuit. So you can see the first integrated circuit. How does it looks like? And at that time, because of lack of resources, how they have developed this thing. Today we have everything, all the resources, but no idea, no effort, nothing to develop this sort of technology, right? So you can imagine how the things have been done, progressed at that time in a more proficient manner. So basically all the components we all know that is mounted onto a single substrate, single chip. Okay, now initially it started with few thousand, now millions, billions of transistors or components are mounted onto a single chip substrate. Integration, we all know that it improves the size, speed, power, and obviously increases the complexity part also. So the main concept is, I have already told, the two important factors: cost, performance. Performance should be high, cost should be optimum. Okay, then only people can work. So that this ICs generally fulfills those criteria part. Okay. Now we all know that how to make these ICs, that we generally people uses the standard lithography process that is used to start from this silica to the IC part, that is the pure MGS, metallurgical graded silicon, and then a series of steps are followed up to make a particular IC1. So that depends on how much, what size you generally want, for including from 2-inch to 12-inch wafers front size. Okay. Now these are the various classifications of ICs that is used for different circuit technology, bipolar junction transistor, BiCMOS, NMOS, CMOS, SOI and the other things. Design style including the gate array, FPGA and the other systems. Design type, analog, digital or mixed signal size, and then small scale integration to giga scale integration. So all these have been improved as per the demand and as per the technology mature to the next extent. So this is somewhat the classification technologies. We have started in 1916 with the bipolar technology and then moved towards from CMOS, BiCMOS, SOI, silicon JA to gallium arsenide. So that is the compound semiconductor material devices. Okay, whether it is binary, ternary or quaternary material. So these all devices are used for the materials are used for different application part in the system. Compound semiconductor material are that is not natural, but basically they are hybrid sort of things. Generally they are made up of different sort of materials. Nowadays people are trying to merge inorganic and organic both the materials. That's why we are using now. Similarly, we know the advantage of digital system, we know the advantage of analog system. Now people have done the research and now converted in the new technology, that is mixed mode signal design. So that is somewhat इसका कुछ advantage लिया, इसका कुछ advantage लिया, नई चीज बना दी. The same thing was like that. So basically our main concern is how we can improve the performance. See, basically there are two aspects that we generally do for. One, either you give a totally new concept, new technology, new idea, right? Second thing is you have this existing technology, let's say mobile or this thing, how you can improvise the performance, how you can improve the things by doing some sort of permutation and combination. Most of the Indians generally follow the second one, right? New idea, new technology की बातें नहीं वो करते हैं, right? So only at that time in 19 or 80s and that time basically the Raman and all those things at that time they have done. But nowadays nobody talks about the inventions, innovation, technology part. What they are doing generally, this is the thing, by doing some sort of permutation combination they are just improving the thing. So just they are adding a small drop into the whole ocean, that's it. Okay, now there are various sort of design issues. Basically when we are dealing with some sort of system in which we have to look for the rapidly growing field domain, and then we have to look for the different factors also, that includes the performance, area, cost and the market part, and that can be managed by the help of different system. Okay. So in any kind of system there are two fundamental aspects. The first one is the theoretical aspect, second one is the experimental aspect, right? So we can't directly go to the experimental part because first we should know about the design area part, right? So in that we have to do the simulation, modeling and then optimization. Once this all things have been done in a rigorously, then only we can go for the experimental part, because otherwise there will be a loss of energy, loss of financial aspects, various things. So it is very important to do the theoretical analysis, and for that we generally do the different things that already Amit ji has told, right, related to the all aspect, that what are the different factors, performance parameters that you have to look into. Once that is done, then only you can move towards the experimental aspect for any kind of system, whether it is device or whether it is a circuit part. Okay. Now you think consumer basically what is their demands, that the material, the device should be smaller, smarter, lighter, faster, cheaper. Can you think that it is very tedious job to fulfill all these demands? They have to work day and night, they have to put their sincere effort to fulfill the consumer demands, and that is somewhat really challenging to make this sort of systems. Now we are moving towards 2 nanometer technology node, right? So that is somewhat very high sophisticated system which we are right now working, and for that the engineers, physicists, scientists, they are doing a lot of things related to that. Similarly, like let me give you one more example related to the origin of universe, that is the experiment that is going on the third Geneva border, that is previously it was known of this Big Bang theory and black hole concept and all those things, but then it came that Higgs boson, that was the God particles, that is the existence of the universe part. So it is basically 100%, 75% dark energy, 25% dark matter that is made up of, and then we are working towards the exploring the existence of the universe. So that is a fundamental thing, and there 10,000 engineers, scientists and physicists are working. So that is a great thing. So Peter Higgs, that was from their side, Bose was from our side. So that is the Higgs boson one. Anyways, let us come to the 2 nanometer technology node. So right now the tech development trends were divided into 2 parts, Moore's law and more than Moore's law, right? So I hope maybe many of you have not known about the Moore's law. The number of transistors gets doubled in every 18 months, right? So basically the concept is the things are, as the transistor size is scaling, the market is increasing. Okay, so that is somewhat the concept, and because of that the size has been shrink in such a way that now the complexity has increased to the greater extent. So you can see how the era has been changed like this one. So smaller the feature, the better performance and cost functions will be there, and similarly the market will grow like exponential way. So it has started in earlier 1960s, and up to 2020s, 30s, it will again going to decay down. So for that we have to think of the new existing technology which can be made in in a more unified manner, so that the things can be made more efficiently, effectively, and in a better uniform manner. Okay, so the things, the advances that has been done in last 10 years from the science to the product level. So initially the things has been expanded. Previously people were working towards the inorganic electronics based material systems. Now they have moved towards the organic electronics based material system, right? So that is somewhat like mobile system itself, right? So a mobile to have for that, so screen is somewhat smaller. So what they have done कि उन्होंने बड़ा वाला small mobile system बनाया that can be foldable and kept into the pocket. So that is the foldable mobile system. I have went to the South Korea, I have seen that sort of system. मतलब चीज़ें बड़ी भी चाहिए, सारी जितनी भी बड़ी हो जेब में भी चाहिए, like that. So that is only feasible because of organic electronics, because that is somewhat flexible, right? So that can be folded and that can be kept into. So people have moved towards inorganic to organic part, and now after that we are moving towards the 2D materials and the nanostructure parts. So that is the advancement that has been done from inorganic to organic, from non-IT to the IT sector, from different new technologies including junctionless transistor, the double gate MOSFET transistors, memristor devices, and so on. Okay, so when we are scaling down anything, obviously there should be several limitations. Every system has some pros and some cons. If it has a loss of 0.00001%, still there is a defect into the system. Okay, so we have to look into some sort of alternate options that can provide a better solution. So for that we are in continuous verge of searching related to the material, related to the device configuration, which can build a standalone system. So you can see how the things have been changed initially. Like I have started with the in 1904 when Alexander Fleming, and previously if you have seen the systems, so that was too bulky, too heavy mechanical systems that were used. The first computer system, that was such a heavy machinery and all these things were there. Right now how we are using the system. So the things have been changed only because of these micro nano electronics or this technology system part. Okay, so for that various sort of important contribution has been made by the transistors, by the ICs and their counterparts related to these systems. So these nano electronics and already has moved towards the different technology, including MEMS and NEMS systems also, that is micro electromechanical systems and nano electromechanical systems, which is integrating the mechanical, electrical and the other system parts. Okay. Now the vision has been also changed in last 10 years. Previously it was very difficult to build the thing where the concept was from how to build to what to build. So initially there were lack of resources. We know that if we have to build the system, then it was really very challenged to build this system, because resources were very challenged to grab and very difficult to manage the things to fabricate this thing. But right now today so many things are there, so that now the changes vision is how we can improve this system to a next further level. So that is has been changed, has been made in the different domains, starting from the mobile phones, from these other systems. पहले हम लोग कौन सा मोबाइल यूज करते थे, वो बटन वाला, right? So that was the thing. Right now we have moved towards these sort of systems. So basically the features, the services have been improved to a next extent. Why? Because the technology is advancing. We are adaptive to change as per the technology changes, and similarly we are going to use those systems, so they become obsolete, right? So we have to make updates as our technology is going to update. So accordingly the things have been changed in different eras also. Okay, now smart systems right now are very important in this century, because this only includes the different systems, whether it is radio, sensor actuator part, or the power related different technology systems sectors that are used. So main concept is, when here we are utilizing the basic fundamental general principles to build a system which can be used for hybrid and interdisciplinary application part. So for that we are using the different sort of sophisticated technology, that is like system on chip, system in package, 3D ICs, and all these systems are nowadays in demand, which can be easily, which are user friendly and which can be easily interactable, which can be easily adaptable. So SoC, system on chip, you all know about, where we are integrating all sort of components onto a one particular substrate. So you can see having application specific ICs, memory devices, they are analog, sensor, communication system, everything is put onto a single board to achieve a more compact system, robust system, and having a better performance features. So that's why people are working towards this sort of technology, so that make the system more proficient. And this one, just a minute, sorry, hello, hello, हेलो, हाँ, नहीं चल रहा है, मैं कर Okay. Similarly, we have one more important domain, that is system in package. So, here what we are doing is we are trying to make a module package where we can first do the array of systems including the different interconnections of ICs. Similarly, having different sort of multiple processing functions like we generally use in the GSM radio part or the video processor, and finally MEMS technology system that includes the mechanical, electrical, electronics and the theoretical systems. So, that is somewhat these technology where we are trying to build the system and packaging in a whole, as a whole. Okay. Now, this system in package and the system on chip both are complementary, correlated with each other, because both are utilized for the desired functions and they generally uses the different technology to make a thing multifunctionable and somewhat more rational and systematic towards the different technology. So, that uses some premature technology and based onto those systems they are integrated onto a single package part. So, you can see these sort of some flexible sort of screens or systems that is utilized and used nowadays because of the organic system module. This is feasible and new development trends have been made for designing these sort of devices, and they are reviewing the previously older counterparts. So, that is only feasible because of the nanostructured materials, that is the carbon nanotubes and the other sort of things. Okay. So, miniaturization means the science of making small things. So, our main concern is, I have already told, the people are having bigger expectations from the smaller products. So, they want to build or integrate most of the systems into that small device itself, so that they do not have to look for the any other options for fulfill their demands. So, for that they have to create a system where we can have a multi-interactive part and multifunctional system. So, for that generally the things have been designed in such a way that it should work efficiently and effectively. The problem again also occurs because if we are going to design that sort of thing, complexity will going to increase and that will lead to the failure into the system, and that may be due to various issues related to the design, various issues related to the not proper estimation or not proper analysis that has been done at the earlier stage. So, that may be lead to the chances of failure and maybe some breakdown, maybe some other complex issues. So, that is possible because of these various factors. So, an urgent need related to careful expertise is required to handle these sort of systems, so that they can work in a proper and uniform manner. So, these are some of the constraints that needs to be taken care of while designing or building any sort of systems. So, the important thing is there is a gap between the technology part and the fundamental knowledge. So, obviously, we have to put some sort of sincere efforts to develop that technology in a most proficient manner. So, for that we have to understand the things that how the system can be built in a proper way, like predictive modeling is somewhat like this. So, we all know that the things should move in such a particular way and we can get the desired output as per our predictions, but the things may change like this one. So, I hope from the diagram something is clear to all of you, right. So, that is somewhat a challenge. Similarly, the different things related to the modeling capability is best thing is that it is quite accurate, robust and efficient. We can do number of iterations and try to optimize the results to get in a desired manner, and using the different system part. Okay. Now, the various important technology domains that needs to be worked on for the human society includes the design automation part, the various work related to the materials and equipment parts. We have to see towards beyond the CMOS technology, and people should work towards the heterojunction system part. Nowadays, people are working towards the hybrid system, so that they can get a better optimal results or solution part. So, that is why that is designed into the two different categories, and now we are moving from more to more than more one, so that we can develop the more proficient system which can work in a good manner. So, vision that is generally made for the next 10 years is somewhat, people have now focused more towards the new nanoscale physics devices and development of these devices for different applications, including the logical part, memory devices and the other extent system. So, similarly, inorganic to organic material systems, where people are working towards flexible and reliable sprintronic systems, and this is carbon based devices system, nanotechnology system, to build a system as per their demand. Now, goals for next 2-3 years, including the fabrication part, people are moving towards the 3D aspect, atomic level systems, where the movement of all these systems at micron, submicron range can be also studied, and related to the electrical, magnetic and the other systems by combining these technologies. So, they are working towards these systems to build a strong tool, and can be utilized for the different application part. Similarly, for the devices role also, they have the different new functionalities that is used, and although there are various challenges that needs to be addressed, and that should be within the range of scope and functionality part. Similarly, the whole architecture including the various nanoscale device research, computational facilities and the interdisciplinary research counterpart, that should be driven for the research oriented application, and that needs to be studied. Okay. So, somehow this is the summary of talk, that technology have already changes our life, and day to day it is trying to improvise the things in a better commercialized way, and it has affected our life in different manners, and the best way is to invent, to explore it, to understand and to try to discuss with all the thing in different aspects. This is somewhat the concluding remark. So, that is somewhat going for this one. Okay, thank you for your kind attention. Thank you.
Any questions from audience side?
बच्चे भी तो बहुत कम है. एटलीस्ट पूरी क्लास आती तो थोड़ा वो होता कि somehow ये भी रहता इंटरेस्ट.